this isn't the only thing that we can point to. We can actually use dynamic memory allocation to. Well, I won't get onto it, but it's a different way of using pointers, and we'll talk about it later in the series. But for the moment, we're just going to point to a variable in our program. So we're just going to declare another integer. Just so you know, a pointer to an integer, so in this case, where it's got int and then the pointer operator, can only point to an int variable. Okay? I'm not sure about it, but it sounds legitimate that a pointer to an int can point to a pointer to an int. So you could have 2 pointers and 1 normal variable. You could have one of those pointers pointing to the normal variable, and then the second pointer pointing to the pointer which points to the normal variable. I'm pretty sure that's okay. But it always has to point to the same type, okay? So we declare an int to use with our pointer to an integer called myInt and assign a value of 15. Then all we have to do to assign the pointer the address is use the pointer's name, so in this case pint, and then say equals and then myInt and use the address of operator in front of the variable name. So in this case and or address of myInt, okay? And we've covered the address of operator, so I won't cover it. And now we have a working pointer called pint, which will point to the variable myInt. So how do we actually output the value that pint points to? Okay, because what actually happens is, remember, a pointer doesn't store the value of the variable it points to. It stores the memory address of the variable it points to. So if we, in this case, output pint, we will actually get a memory address. So we will get a memory address instead of what we want is the actual value, so 15. So how do we output the value which we are storing the memory address of? Okay, really simple. All we have to do is use the asterisk again, but in a different way. In this way, it's called dereferencing a pointer, and we do it by putting the asterisk before the pointer name in any situation where we would be modifying the value that the pointer points to. Okay, so the asterisk operator actually does several things. It allows us to create pointers when it's after the pointer type and before the pointer variable name, and it also allows us to dereference pointers. I don't actually know, I haven't actually tested it, but as far as I'm aware, when you're dereferencing a pointer like this, you can't have any spaces in between. Let's give this a try, I just want to check. Okay, it does actually work, but I've never seen it done like that before, where there's a space. It's always just good to keep it like that, because when we get later on where we have pointers to classes and we're trying to access member functions and stuff, you won't understand any of what I'm saying, but basically what I'm trying to get through is keep it formatted like this where it's right next to it, because it will make it a hell of a lot easier. And also it helps you distinguish between declaring a pointer, because when declaring a pointer, it's more you'll see the space between the variable name and the pointer operator a lot more than you'll see this. So if just by default you have in your brain that when dereferencing it's always by the pointer, it will allow you to say, oh, what's that? It's dereferencing. What's that? It's declaring. What's that? Declaring. What's that? Dereferencing. So there you go. And so this allows us to dereference a pointer, which means get the value of the variable that it's pointing to. So let's run this. So first we have that memory address. Notice that the memory address changes. I just remembered I talked about that in the previous tutorial, or not the previous one, the one on the address of operator. I think that's 3 tutorials ago. So I won't talk about that again. But yeah, so basically what's happening here is first we're outputting pint, so that's the actual variable pint, which contains the memory address. then we're outputting the value that is at this memory address, okay, which is 15, which is the same as my int, because it is my int. That's the value inside my int 15, and we do it by dereferencing the pointer. And remember how I said when we can use dereferencing to, in any case where we are changing, or in any case where we're using, I guess, the value that the pointer points to. Okay, so we can also dereference the pointer. In dereferencing it, we can change the value stored inside my int, because we say, okay, to C++, to the compiler, we're saying in this statement, what this will do, I'll just walk through it quickly, is dereference pint equals 20 will change the value inside my int to 20, okay? And the reason is because we're saying, okay, change the value that pint points to, okay? So change the value that we're dereferencing to 20, okay? And then just to demonstrate the change, I'm going to output a dereferenced pint again. Obviously, we're pretty certain that that's going to be 20, but I'm also going to output my int to see if it's changed, and you probably saw it before, they're both 20, so there you go, okay? That's, as you can see, we've changed the value inside my int via the pointer. It is important to understand that a pointer just contains a memory address which we can use to manipulate the variable at that memory address. When we change the value by doing that dereference pint equals 20, we are changing my int's value, okay? That's really important. We're changing my int's value, not pint's value. Pint is just a pointer to a variable. So, in the statement, although it may look like we're changing the value inside pint, we're not, because we're dereferencing pint, which means essentially, when it comes to running the program, I mean, it probably won't, but the idea that's behind it is, what this statement will turn out to look like will be something along the lines of these. So, at the point of running, these are effectively the same statements, okay? So that's really important to know. Even though it looks like we're changing the value of pint, we're not changing pint at all. Because let's just change this quickly as well. Add on. We'll output the value of pint, so the address. You'll see that the memory address up here that we first output is the same. Then we output a dereferenced pint, 15. Then we change the value inside my int using a dereferenced pint to 20. Now they're both 20. And then we output pint again. And it outputs the same memory address as before. So this one is after we change the dereference pint. That just goes to show that when we change a value using a dereference pointer, we're not changing the pointer's value. We're changing the value that the pointer points to. Okay? Now I've got really dry lips from saying pa all the time. So I'm going to end this tutorial now. Thanks for watching if you did, and I'll see you guys next time.